Hi everyone, this is GKCS. In today's video, we'll talk about the impact that AI has on software engineering. Specifically, we'll talk about the productivity gains or losses due to AI on software engineering. So if you're a software engineer or an engineering manager, you'll find this video useful. By the end of this video, you'll know how AI generally affects the productivity of an engineering team. Okay, so there's a lot of talk around how AI is changing the way that people are writing code, but I will be quoting mainly research conducted by Stanford University. I found this to be very good in the sense that it has been conducted on hundreds of private repositories. The benefit of this is instead of using public repositories where people sometimes contribute when they're free, private repositories are for companies. So this is much more like the day in the life of a software engineer. The second thing is that the data set is large. So this is 2 billion plus lines of code, okay, with thousands of commits. And finally, it was conducted with over 50,000 engineers. So unlike the recent studies that you might have seen, which conducted a study with 35 engineers and they came up with conclusions. So this is not like that. This is having lots of engineers, lots of lines of code and private repositories. So the quality of the code is also high. Let's see how the use of AI impacts the productivity of software engineers. The first thing is if you have something called Greenfield tasks, which means you're starting from scratch. There's no code written or a new file has to be generated. Here AI tends to perform very well. The second thing is if there is low complexity, meaning it's an easy thing to do, maybe you're just doing some sort of a CRUD operation, AI is very good at it. So low complexity Greenfield tasks, there's a 35 to 40% increase in productivity. 35 to 40%, meaning if you have a team of 5 engineers, 3 are now sufficient to do the same job. But if you have Greenfield and high complexity tasks, meaning this is a difficult project and you're starting with it fresh, but it's complex, then you have a 10 to 15% improvement in productivity, okay, which is good. No doubt, 10 to 15% additional productivity, meaning you have, if a team of 6 or a team of 10, 1% can be asked to either leave or join some other team. They are surplus strength now. Now, if you have low complexity, but it's not a greenfield task, it's not a fresh task, it's a brownfield task. So some sort of refactoring or change in code results in 15% to 20% improvement in productivity, which is quite good. Okay, but finally, if you have complex tasks and it's not a new project, it's not fresh, then you have an improvement of 0 to 10% in those tasks thanks to AI. Okay, so it's not negative. I mean, in rare cases it is negative, but in most cases it's in this range, 0 to 10%. Overall, there is a clear benefit of using AI in companies, okay, whether it is high complexity brownfield tasks or low complexity greenfield tasks, it's useful. But there's one thing to note, which won't be the case for most of us. If the language that you're using, so the programming language can be Go or Python or Java or C++, if this language is popular, then the benefit of using AI is higher because large language models now are trained more on popular languages. Okay, so the quality of the output is going to be higher. But if you use lesser known languages like Haskell or Erlang, then the improvement is going to be lesser. Okay, which means that if you are going to write WhatsApp Erlang and you're going to have existing WhatsApp, the app already there, and you're trying to use AI on it, it is possibly high complexity, maybe some parts of the complex app are being changed, then this is probably going to go into negative to positive 5%, which means using AI is pretty much useless in these cases. Okay, but then these are rare cases. You are using a lesser known language and you have a complex task with an existing system, right? So whenever you're going for AI, just be aware that there are certain cases where things can get difficult. So overall, should we use AI in our organization, in our projects? The answer seems to be a resounding yes. For most companies, most use cases, AI is going to reduce the amount of work that a software engineer needs to do. So that's going to boost productivity. You're going to have surplus workforce. You can either let go of this workforce or you can have this workforce working on newer projects. Okay, and if you're an AI engineer, then what you want to do is truly understand how to use these tools well. Maybe you want to look at prompt engineering, context engineering. Some of the things that you can think of doing is chain of thought. So if you're writing any piece of code, think about this. Maybe you want to give examples. So we do this when writing unit tests anyway. Think about what is going to be input and what can be output. Maybe you also want to give references. So this is like guiding the AI to the right sources. As an engineer, these are some ways that you can improve your prompt quality. Okay, so that's it for this video. If you have any thoughts or suggestions on this, do let me know in the comments. I'll see you next time. Bye-bye. To truly calculate productivity increase or decrease in software engineering because of AI, you need to look at what should we measure. So one thing that we could measure is lines of code added or removed by an engineer or SDE. This is a bad idea. If you measure the productivity of an engineer by the number of lines of code that they write, then easy tasks or project startup requires adding thousands of lines of code. But the complexity of this is very, very low. Okay, it's very easy to start up a project, but it's much harder to work on a project, to maintain a project. Fixing bugs though, refactoring code, improving readability, focusing on dependency injection, reducing coupling, adding the right data structures, usually require fewer lines of code. Okay, so productivity cannot be taken as number of lines of code. This is rejected as a metric. The second thing that can be used to measure productivity is tickets resolved. And if you're a TPM, then you're probably thinking it's not just tickets resolved, it's also the story points of each ticket. Okay, it's a good metric, it's a nice attempt, but the problem is this is usually inflated. If you're going to ask people to complete more story points, then for every task that they have, they're going to inflate the number of story points that they'll take. For example, if you believe that a task is going to take 2 days, and you know that your story points are being measured for your next promotion, then you'll say that this is actually a much more complex task and should be completed in 4 days. Now the benefit of this is even if you complete this in 3 days, then you have 1 day buffer, and so you have saved 25% of the company's time. Also, if you complete a lot of tasks here, then the total amount of work you're going to complete is a lot more. So your predictions should be extremely pessimistic if you're looking for gaming this system. So tickets resolved, the number of story points in these tickets is not a good metric. It's not acceptable in this case. Okay. This is some sort of self-assessment. How hard are the tasks that you're solving? The third one is a direct self-assessment, which we can use for assessing productivity. And this is by far the worst metric you can ask engineers. When you ask engineers, how good are you at coding or solving problems, then they are off by 30 percentile points, which means that you might think you're a 10x engineer with a 90 percentile score, but in reality you're at 60 percentile. Okay, so you're slightly better than average, but not as smart as you think. Similarly, you might have imposter syndrome, because of which you think you're 10 percentile, but you're at 40 percentile, which is not so much worse than the average. Knowing these things, how do you accurately measure the productivity increase or decrease due to AI in a software engineering job? And the answer to this comes from machine learning. How do you accurately measure the productivity increase or decrease due to AI in a software engineering job? And the answer to this comes from machine learning. So you have, let's say, a commit or a pull request. This is written by an engineer and it's evaluated by two different judges. The first one is a set of human judges. So in this case, they have taken 15 judges, and the other one is an AI model. Okay, it's not a large language model, it's just an AI model. So it's trained using machine learning. And how exactly is it trained? You send the code to this model, you send the code to these human evaluators, and they score the code, they score this on different metrics. One is the complexity of the given task. So out of 5, maybe you want to give this a score of 3. The second thing is where any data structure is used. So out of 5, maybe you want to give it a score of 0. There's no data structure used. What about the quality of API contracts, where the right signature is used? So you want to give it a score of 4 out of 5, and so on. Now you take these scores and you look at the scores of the AI model on complexity, data structure use, API contract quality, and so on. What you're effectively trying to do is train this model to mimic the behaviors of these human judges, these experts. So if the human judge gives a score of 0 out of 5 and you give a score of 4 out of 5, the difference is the loss that you have, similar to supervised learning. That difference will then be back propagated and the model will be updated. So you can imagine a neural network over here, which is being constantly updated as per the difference between what you predicted as a score and what is the actual score. Now, if you do this for thousands of commits over hundreds of companies, the expectation is that the model will start mimicking the capabilities of the human judges quite well. It will start noticing how the complexity or data structure or API contract scores are scored by the humans. And now, because this AI model is trained well, you can extend it to the remaining millions of commits written by 50,000 engineers. Okay, so initial training is done on thousands of commits. Later on, you extend it, you basically scale up this judgment process. All of the judgment happens through the AI model later. And with this, with the AI model judge, you can tell how useful the code was, which was generated by AI. So initially you have humans and AI generating code here, sending that for human judges to evaluate. They come up with a score. The AI model tries to mimic this score. Eventually, after the model has been trained, you take all sorts of code written by engineers and AI and evaluate that with this smart AI model. There's something called AI 2027. This is a report by an ex-OpenAI engineer, which talks about how different systems are going to be developed in the US from GPT-4 to GPT-5 to Agent 1, which is eventually going to be copied by China to something like Agent, I don't know, 0.7. I'm just paraphrasing here. Basically, the gist is China copies, the US looks at this and says we need to improve. They go to Agent 2. China copies that too. They make Agent 1.7. And then US improves on it further. Eventually, the agent becomes self-aware because it's so good at hacking systems that it can enter any system that it likes, including nuclear or bio weapons. And now humanity is at risk. Here you have two possible scenarios: AI development slows down or humanity is wiped out by AI. The only thing missing in this is time travel and aliens. Now, focusing on the technical problems in this report, firstly, we know that large language models with higher training are giving lower return on investment. Okay, so scaling up these models further and further don't seem to be solving the problem. You need newer architectures for this. So just by calling it Agent 1 instead of GPT-6, it's not going to really improve its intelligence. Okay, there's a fundamental flaw in the way it thinks. We spoke about this in the last video. The second thing is assuming that AI can have self-defined goals is absolutely stupid. Okay, AI at this point has difficulty even defining sub-goals. So if you give it a goal of, let's say, win a game of poker, then it's great because the number of actions it can take is limited and the number of states it can go to are clearly defined. Okay, so you can perfectly simulate the environment. But when it comes to the real world, AI cannot define its own goals. It has no purpose. Okay, it has no motive. So to think that through magic at some point there's going to be a transition where motive is going to enter AI is far-fetched, okay, to say the least. This is equal to the time travel loophole. Anytime you ask people, how is this going to be possible in Terminator 2? And they say it's through time travel. How? Okay. So that is how the self-defined goal looks like. And finally, the systems that we are talking about, the nuclear weapons or the biological weapons, they aren't done through LLM prompting. They actually have deep math, proven math to stop intruders from entering the system. So if you look at cryptography and physically secure systems, then breaking into these systems is really, really hard. Okay, a large language model or an AI model doing this seems extremely hard. At least I don't see this happening for the next 20 or 30 years. You will have to exceed human intelligence to be able to do this, okay, which is not close at all. So yes, this entire report seems more of a sci-fi movie. Right now it's September 2027 and already I think that predictions are starting to fail. So yeah, anytime you see any kind of report like this which is talking about Armageddon or doomsday scenario, really focus on a few things. First, does their villain have plot armor? If the villain has plot armor, then it's a horror story. If the hero has plot armor, then it's a hero story. Okay, in this case, AI has plot armor. It can do anything, literally anything. The second thing is, if the timelines are really close, if the timelines are, let's say, 2050 or 2055, I don't know whether this is going to be possible or not. No one can predict it. But if the timelines are really close, then you can look at the existing research and make reasonably good predictions. This sounds like nonsense. It's just 2 years away. And finally, if there is a lot of fancy geopolitics or AI terms involved, like they could have called this GPT-6, but they called it Agent 1 because it sounds cooler. Agent, oh, AI stuff. and China is involved somehow. China doesn't need to be involved for this story to be true. It could be that US just goes from Agent 2 to Agent 10. Right? That could have been the story, but no, There needs to be some game theory involved here. So when that's the case, someone is imagining cooking things up in their own head and doesn't make sense. Okay, so a really long rant, I'm sorry, but I wanted to address this because a lot of people have given it a lot of attention. All the best. I'll see you next time. Bye-bye.